Hey everyone, welcome. If you're a focused learner trying to pick up a new skill fast, well, you've hit the jackpot today. We're taking a structured journey through this explainer, and I promise you this. By the time we wrap up, you're going to go from absolute zero to writing real, functional Python programs. We are talking about the exact same programming language that powers massive platforms you use every single day. Think YouTube, Instagram, Spotify, and Dropbox. It's incredibly empowering, and you don't need any prior experience. Just bring your attention and a willingness to learn. Okay, let's dive into this because I absolutely have to bust a massive myth right off the bat. You do not need to be some sort of math genius or a wizard to start coding. Honestly, programming isn't magic. It's just a series of really straightforward instructions that we give to a computer to automate boring, repetitive tasks, analyze data, or build applications. Think of it as writing a very, very specific recipe for your computer to follow. Here's our roadmap for today's explainer. Setup and first program, variables and data types, inputs, strings and operators, logic and loops, and finally, lists, tuples, and projects. Basically, we're methodically building your toolkit block by block. Let's get to it. All right, Section 1, Setup and First Program. So, Step 1, just head over to python.org, hit Downloads, and grab the latest version. Now listen closely here, because this is absolutely critical. If you're on Windows, you must check the little box that says Add Python to Path during installation. If you skip this, oh man, your computer won't know what Python is and you're going to be pulling your hair out later. Trust me. Step 2, we need a place to actually write our code, what we call a code editor. We're using PyCharm Community Edition. It's totally free, super powerful, and literally perfectly designed for beginners. Once you've got that installed, Step 3 is just creating a new project, and inside that, a file called app.py. This little file, that's our blank canvas. Okay, let's get you that immediate dopamine hit of writing your very first program. Inside that app.py file, you're going to type exactly what you see here. The word print, followed by parentheses, and inside quotes, hello world. Now this print command is a built-in Python function. Its whole job is just to take whatever text, or what we call a string of characters, you put inside those quotes and display it right at the bottom of your screen in the terminal. When you hit run, boom, those words pop up. I know it seems super simple, but you've literally just commanded the machine to speak. Huge congrats! You just executed your first Python program. Moving right along, Section 2, Variables and Data Types. Now, what's really interesting about this slide is how computers actually store information. Think of a variable as a labeled box just sitting in your computer's memory. You write age equals 20. Boom, you've just created a box, slapped the label age on it, and dropped the number 20 inside. If you print age, the terminal spits out 20. But hey, variables are, variable. On the very next line, if you type age equals 30, you've just swapped out the contents of that exact same box. And since Python reads and executes your code from top to bottom, the final value it prints out will be 30. So inside those labeled boxes, we can store all sorts of different data. Here are the 4 core data types you're going to use constantly. Integers, those are your whole numbers, like 20. Floats, those are numbers with decimals, like a price tag of $19.95. Strings are just text, and they are always wrapped in quotes. And finally, Booleans, which represent a simple true or false. Now, a vital warning here, Python is incredibly case sensitive. Like if you type a capital T for true, Python totally gets that it's a Boolean. But if you type a lowercase t, your program will literally crash on the spot with an error. Precision is pretty much everything in programming. Next up, Section 3, Inputs, Strings, and Operators. So, here's a question. How do we actually make our programs interactive? I mean, a program isn't very fun if it can't listen to you, right? Well, in Python, we do this using the input function. What it does is pause your program, wait for the user to type something directly into the terminal, and then it captures that text. That way, you can store it right into a variable, like, say, asking for a user's name so you can greet them. But watch out, because here's a classic beginner trap. Let's say you ask a user for their birth year to calculate their age. If you try to subtract their input from the current year, say 2026, your code is going to break. Why? Because the input function always captures user input as a string of text, always, even if they type numbers. So you're literally telling the computer to subtract a word from a number, which, makes zero sense. The magic fix here is type conversion. You just wrap that birth year in the int function, which magically converts that text into an actual usable integer number before doing the math. And by the way, you can also use float, string, or bool for other types of conversions too. Now, strings themselves are absolutely powerful in Python. They come with these built-in abilities called methods. Say you have a string, you can just tack on .upper to the end of it, and it converts the whole thing to uppercase. Or you can use .replace to swap out specific words. You are going to use these methods constantly to clean up messy data that users type in just to make sure your program can actually read it. But keep in mind, these methods don't destroy your original string. They just spit out a shiny new modified version. Oh, and you can also use the word in as an operator to search, like asking if the word Python is in your string. That'll return a Boolean, true if it's there, false if it's not. Pretty cool, right? And this brilliantly illustrates how Python handles standard math. It's basically just like a calculator. We've got our standard arithmetic operators, addition, subtraction, multiplication, which uses an asterisk. We even have double slashes for integer division, which completely drops the decimal, and double asterisks for exponents. And yes, normal mathematical order of operations, like doing multiplication before addition, absolutely applies here. Just use parentheses if you want to force a specific order. Then we have comparison operators. Less than, greater than, double equals to check if two things are exactly identical, and an exclamation mark followed by an equal sign for not equal. These comparison operators, they will always return a true or false answer. All right, let's keep this momentum going. Section 4, Logic and Loops. It's time to give our computer a brain. This is exactly how a program makes decisions, using if, elif, which is just short for else if, and else statements. You basically give Python a condition. If the temperature is greater than 30, print hot day. If it's not, the computer automatically moves down to the elif statement and asks, okay, is it greater than 20? If yes, print nice day. And if all those previous conditions fail, the else statement is there to catch everything remaining, printing cold. The beauty of this setup is that only one specific block of code runs, entirely depending on which condition gets met first. Now, what if you want to run a piece of code multiple times? Enter loops. These are total lifesavers that save you from reading the exact same code over and over again. First up, the while loop. It simply says, hey, keep repeating this block of code while this specific condition remains true. Like, while a number is less than 5, print it, and then add 1. Alternatively, we have the for loop, which is amazing for iterating over a collection of items, like going through a list of names and handling them one by one. You can also pair this with the built-in range function. You give it a start, a stop, and a step amount, which gives you incredible fine-tuned control to generate exact sequences of numbers instantly. Let's move to and see how this builds into our final topic, Section 5, Lists, Tuples, and Projects. So we now know how to create individual variables, right? But what happens when we have, say, 100 names or 1,000 data points? That is exactly where lists come in. Lists store multiple items together in a specific order. You can access any of these items using an index number wrapped in square brackets. But, and this is important, remember that in Python, counting starts at 0. I know, programmers are weird like that. So index 0 gets you the very first item. Index -1, that's a super neat trick that actually wraps around to grab the very last item in the list. You can even slice lists to get a smaller portion, like just grabbing items 0 through 3. And just like strings, lists come with their own powerful methods. You can use .append to add a new item to the very end, .insert to sneak an item into a specific spot, .remove to delete something, or use the len function to instantly find out exactly how many items are sitting in your list. So, the crucial point here is understanding the difference between lists and tuples. Lists use square brackets, and they're what we call mutable. That's just a fancy way of saying you can change them. Add items, remove items, alter values, whatever you want. Tuples, on the other hand, use parentheses, and they are immutable, meaning once you create a tuple, it is locked down. You cannot change it, you can't add to it, and you can't remove from it. If you try, Python's going to throw an error right in your face. Basically, you want to use tuples when you have data that absolutely must remain constant and completely safe from accidental changes throughout your program. And wow, that brings us to the end of our crash course. But really, it's just the very beginning of your coding journey. The absolute best way to truly learn this stuff is to get your hands dirty and do it. You now possess a solid toolkit: variables, data types, inputs, type conversions, logic statements, and loops. So I'm challenging you. Open PyCharm right now and try building these real-world mini projects. Ask a user for their weight, ask if it's in pounds or kilos, use some logic to convert it, and print the results. Try using a loop to print out a descending pattern of stars. Or write a program that predicts the exact year a user will turn 100. Apply what you've learned today, keep practicing, and honestly, you're going to be amazed at what you can build. But I want you to ask yourself, once you master these basic building blocks, what problem in your own life are you going to automate first? Thanks for joining this explainer, and happy coding.